Have you tried running a heavy video editing program only to have your laptop freeze, heat up, and sound like it's preparing for takeoff? Traditionally, if you or a business wanted to do serious computing, you had to buy all the physical equipment yourself. You were forced to build and maintain your own personal power plant of hard drives and processors just to keep things running. But imagine if you could tap into all that massive computing power without actually owning the machines. What if you didn't have to keep a huge, expensive tower under your desk at all? Buying and maintaining physical hardware is incredibly expensive. This ownership model creates a massive financial barrier that stops many everyday users and new businesses before they can even start. This is the core of cloud computing. It moves all that heavy processing, software, and data storage off your personal device and onto the internet. Think of it like plugging a lamp into a wall socket. You don't need to know how the power plant 50 miles away works. You just plug in and access the grid. The cloud turns computing into a shared utility, just like your power or water. The companies running these platforms handle all the messy details in the background. They hide the complex network infrastructure behind simple, user-friendly screens, so you can just click a button and get to work. This shift transforms technology from a physical product you have to buy into a utility service you simply rent. The cloud consists of a massive collection of physical servers and hardware located in remote buildings called data centers. These data centers use a concept called resource pooling. They group massive amounts of processing power together and share it among thousands of different users at the exact same time. This diagram shows how that connection works. You can see the central network cloud in the middle acting as a bridge, linking everyday devices, like your home computer, to powerful back-end servers. By centralizing everything, IT professionals can easily manage security for everyone at once. Plus, it gives you access to a level of hardware power that no individual could afford on their own. Because these remote servers are doing the work, your files and programs are always on. As long as you have an internet connection, you can access your data from any device anywhere in the world. The system adapts instantly. If a website gets millions of visitors, the cloud stretches capacity for the rush, then shrinks down. In this pay-as-you-go model, costs scale in perfect sync with the resources consumed, just like an electricity bill. These traits combine to remove the risk of guessing how much power you'll need. You don't have to pay for idle servers or worry about running out of space. Cloud computing is organized into distinct service layers, which vary depending on how much technical control you need. This table shows 3 layers. At the foundational infrastructure layer, businesses rent storage and hosting instead of buying servers. At the platform layer, developers rent environments to build apps. At the application layer, we use web software, eliminating local installations. Whether you are a raw developer or a student using a web browser, there is a specific layer of the cloud tailored to your technical needs. Moving your work to remote servers does create a specific vulnerability. The entire system relies entirely on your network connection. If your internet connection is slow or drops out, accessing your data or web applications becomes painful or impossible. Additionally, many web-based applications today lack the full range of features found in traditional desktop software. While the cloud removes the limits of your local hardware, it replaces them with the strict limits of your internet bandwidth. While those trade-offs are real, the payoff for the average user is a significant drop in hardware costs. Since the remote servers do the heavy lifting, your personal PC doesn't need a high-priced processor, massive memory, or a huge hard drive. This allows startups to launch without massive capital and enables students to work efficiently on basic, affordable laptops. By removing the need for expensive hardware, the cloud acts as an equalizer, giving a first-year student access to the exact same computing grid used by the world's largest corporations.